level or maximum level, that is a VP, or you can say that it's a VM. So it increase, reaches to its peak level. After that it doesn't beyond the level of peak level, so it starts now decreasing, and again it reaches to the 0. Now again it increasing, but with the negative direction. Again there is one peak level from the negative side, so it reaches to that level and again decreasing and reaches to the again 0. So this is at least one cycle, 0 to t by 2, and for the t, so 0 to t is the total time period. Here what happens, the signal travel from the 0 to t, but with the different kinds of interval. The value of that instant is differ than the value of that instant. So you can see that this is t1, this is t2, this is t3, now this is somehow t4, this is somehow t5. So all that instant has the different values. So this is known as a instantaneous value. So we can write like that, your V equals to Vm sine omega t, or you can say that Vm sine theta. So this is the instantaneous value of the voltage. If you are talking about your current, then it's same for your current, I equals to Im sine theta, or I equals to Im sine omega t. So this is known as a instantaneous value. So we can see that the P equals to V into I, the normal equation of the power, where your V is an instantaneous value, where your I is also instantaneous. So you put the value of V, that is a Vm sine omega t. Omega t is the angular frequency. You can also prefer the theta, whereas your I equals to Im sine omega t. Now multiply both the equation with each other, you can get that P equals to Vm into Im sine omega t into sine omega t. So ultimately you can write like that, sine square omega t. Now mathematically just solve the equation. You can also put the 1 minus cos omega 2 t instead of writing the sine square omega t. So put the value of 1 minus cos 2 omega t by 2 instead of sine square omega t. So the equation such like that, P equals to Vm into Im into 1 minus cos 2 omega t by 2. Now 2 is a reciprocal, so individually dividing that, we get that P equals to Vm Im by 2 minus cos 2 omega t, Vm Im cos 2 omega t by 2, because Vm Im is a multiplier with the into the bracket of 1 minus cos 2 omega t. So individually write like that, or multiply the Vm Im, and you can also use the reciprocal 2 individually. Now from the above equation, it is clear that the power consists of the two parts. You can divide that equation into the two parts. The first part is a Vm Im by 2, the second part is a Vm Im cos 2 omega t by 2. So here we have just two cases, the case 1 which has the Vm Im by 2, and the case 2 that is Vm Im cos 2 omega t by 2. Now the first case, that is a Vm Im by 2, this is a constant power component, there is no variable term. So you can just you can just assume that this one is a constant power component, this component is a constant, fixed. Now what is your variable component? That is a Vm Im cos 2 omega t by 2. Why? Because cos 2 omega t is a variable term. This is the cosine signal. So this one is your variable or your dynamic component. Here having the double frequency. Now the average value of the variable power component over one cycle is almost 0, because at the end of the almost one cycle, the power consumed by that is almost 0. So the average power consumption is given by PAV, AV for the average, Vm Im by 2, because value of the cos 2 omega t is almost 0. So PAV, that is average power, equals to Vm by root 2 into Im by root 2, because 2 you can write like that. This is P AV equals to Vm Im by 2. You can use like that. Im 2 is what? It is root 2 root 2. So ultimately we can write like that, Vm into root 2 or Im by root 2. It is nothing but you can just write that Vm Im by 2. Or we just know that the Vm by root 2 is nothing but the RMS value. Im by root 2 is nothing but the IRMS value. So substitute the value of Vrms and IRMS into the equation of average power. You can just get that PAV equals to Vrms instead of writing the Vm by root 2. Put the IRMS instead of Im by root 2. Now generally the RMS values are indicated by the capital letters. So PAV equals to V into I, and V is nothing but the IR. So ultimately substitute the value of IR into equation of V. You can get that PAV equals to IR into I. So I into I, that is I square. And so we can write like that, average power equals to I square R watt. So hence we can just prove that for the pure resistive circuit, the power consumed by that circuit is I square R. It is proven. The next question, derive the formula for the equivalent resistance when the n resistors are connected in parallel. When the n resistor, this is somehow I am just drawing the circuit for the n resistor. This one is resistor R1, the two terminals of resistor, second resistor R2, resistor R3, somehow resistor R and resistor. So how you make the parallel circuit of a resistor? All the first end of all the resistors are connected with each other, and the second terminals are also connected with each other. So this circuit is known as a parallel resistor circuit, where your n number of resistors are connected in such like that. So this is known as the parallel circuit, where you are connecting all the resistors with the same line. This is known as a series circuit. So we just go through that circuit and solve the equivalent equation for the equivalent resistance for the parallel circuit. When the two or the more than two resistors are connected such like that, the one terminal is connected with the other terminals. This one is called as a parallel circuit, which I shown from the figure. In the parallel circuit, all the resistors get the same voltage. As we all know that voltages are the same for the parallel circuit, whereas the current is same in a series circuit. Now as for the figure, if we are just taking for the three resistors, then what happens? R1, R2 and R3 are connected in parallel with the supply voltage V. So all the resistors R1, R2 and R3 get the same voltage V. But definitely the current passing through R1, passing through R2 and passing through R3, it is different, or it is divided. So all the resistors get the same voltage V, but the current passing through each branch is inversely proportional to the respective resistor, which I am telling you. Now the addition of the branch current is equal to the equivalent flowing through the supply current I. This is such like that. If you are just applying any voltage, that V, and whatever the current passing through that circuit is divided, such like this one is suppose I, this one is IN, this one is I3, this is I2, this is I1. But if you are just taking the addition of all the current I N, that become your main current I. So the individually passing the current through the individual branch of the resistor, it equal to your main current I. So making the equation such like that, your V equals to supply voltage, I is the total current passing through the circuit, I1, I2 and I3 are the current passing through the branches individually from the R1, R2 and R3. So just putting the value of all this in the equation of I1, I2 and I3, take the summation of these three, we get that I equals to V by R. Voltage is the same, I1 equals to V by R1, but the resistor are different. I2 equals to V by R2 and I3 equals to V by R3. So we cancel from the left and the right side. So we just get that 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equation for the resistor when the three parallel resistors are connected such like that. But if we are connecting the n parallel resistor, the equation become that 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3 up to 1 by Rn. So this is the equation for n parallel resistor connected in a parallel form. See, now the power loss in each resistor is P1 equals to I1 square R1, individually resistor power loss, P2 equals to I2 square R2 and the P3 equals to I3 square R3. So the total power becomes P equals to P1 plus P2 plus P3. So now putting the value of that, we just get that P equals to P1 plus P2 plus P3. Now substitute the value of P1 equals to I1 square R1, I2 square R2 into P2 and I3 square R3 into P3. We just get the value of P equals to I1 square R1 plus I2 square R2 plus I3 square R3. This is the total power consumed in the parallel circuit. Just some of the parameters or some of the facts for the parallel circuit are like that. The every resistor gets the same voltage. This is the first truth for the parallel circuit. The value of the current passing through each resistor is inversely proportional to the related resistor, or you can say that the value of the current is different. The addition of the current in each resistor is same as the supplied current. So whatever the branching you are dividing, I1, I2, I3, I4 or IN, making the summation of all the n current, this becomes the equivalent current passing through your supply voltage V. The total power circuit as a summation of the individual power of the resistor. It is P equals to P1 plus P2 plus P3. Making the summation of all the power loss in individual resistor, summation is equal to the total power loss. These are the truths for the n parallel resistor. Now just move towards the next question. Again, it is the optional question for the question number 2b. Derive the formula for the coefficient of the coupling between the two coils having the inductance L1 and L2. Here the multiplication between the L1 coefficient of the coupling, that is M, or you can say that it's a K, for the inductances of the coil L1 and the for the coil L2. Thank you.